let's start with the next problem of the CSES problem set, that is permutations. And this question is really based on implementation again, and we will see how to solve it. So what the question says is that we have to print a permutation of an integer which is beautiful if there is no adjacent element whose difference is 1. So if you are not aware with the word permutation, let me make it clear that if I let's say if I take 5 elements, that is 1 2 3 4 5. So basically permutation is a kind of set which includes the number from 1 to n, whatever the n is mentioned, and basically they are juggled in the way, मतलब ये एक दूसरे की positions exchange कर सकते हैं, and they will be the permutation of the number. For example, if I talk to 2 3 4 1 5, this is also a permutation of 1 to n, where n is equals to 5. Okay, so I can talk 1 4 5 3 2, this is also a permutation. So basically this is the permutation of number n where n is equals to 5. For 6 also you can add some number, a number 6. Also if I say that I have to take the permutation of n, then we have to make it clear that the number should be between 1 to n, that no number will be exceeding n and no number will be less than 1. Okay, so basically this is the overall definition of permutation. Okay, now let's move to the problem. So the problem says that we are given a number n and we have to print its permutation in such a way that no adjacent elements difference should be 1. Okay, so what I mean to say is if we try to print, okay, let's see, if we try to print like this is also a permutation of n equals to 5, but the difference between adjacents are always 1 here. Okay, so if I write like this, then this can be a valid permutation because difference is here 2, here 2, here 3, here 2. Okay, so this can be a valid permutation for n equals to 5, and we can call this permutation beautiful. Okay, because it satisfies our condition. Okay, so we have to print this. So how will we do this? Okay, so let's understand some of the base cases here. That let's say if n equals to 1, then what will be the case? We will always having one element. Okay, तो अगर n 1 है तो we will always be with the element जिसके आगे ना element है कोई, ना पीछे कोई element है. Okay, तो n equals to 1 में हमेशा एक केस आंसर पॉसिबल होगा, that is 1. Okay, if I talk about n equals to 2, okay, तो इसके दो ही permutations होंगे, 1 2 and 2 1, and in both of the cases the absolute difference will be 1. So for n equals to 2 there is no possible way to keep a permutation that will be beautiful. Okay, now let's talk about n equals to 3. So again this will be one permutation, 1 3 2, this will be one permutation, 2 1 3, this will be one permutation, 1 and also 3 2 1, this can be also one permutation. So basically if you write all the permutations of it and you observe that there will be at least two elements whose difference will be 1. Okay, so again if I talk about n equals to 3, there is no beautiful permutation possible. So these were the basic test cases in which the beautiful permutations were not possible. Okay, so we talked about n equals to 1 2 3. Now let's build our solution. Let's say we have to take 4, so we will be having 1 2 3 and 4. So a basic thing we can observe here is that if we keep even numbers first and odd numbers at last, if we keep our elements arranged in this way, we will never have a difference of 1 between any two adjacent element. Okay, so let's check it for 5. We will be having 1 2 3 4 5. What I said was that we will keep the odd even elements first and odd elements afterward. Okay, so you can check. If I talk about 6, then we can again see that these are the elements present in 6. We can keep the even number first and odd number 1, 3 and 5 afterwards. And it's up to you, you can either keep the odd number first or even number first. Okay, so it's up to you. Basically what I will be doing, that I will be keeping the even number first and odd number afterwards. Okay, so this will be the kind of implementation. So what we will do, that we will first check for our base cases, check for our base cases. Okay, which is n equals to 1, 2 and 3. In these two cases no solution will be present. In this case only one solution will be present. Okay, so and after that if n is greater than 3, then we will print even first and odd at last. Okay, so let's see how will we implement this. So what we are given, that we are given a number, let's say n, and we have to print the permutation. Okay, okay, so let's first write our base cases, that if n is less than 4 and then n is not equals to 1, so in this case no solution will be possible. As we talked, no solution will be possible. Okay, else what we talked, that we will first print the even numbers and then afterwards we will print the uh, odd numbers. Okay, so let's take two pointers, I uh, and long g equals to 2. Okay, so what I'll be doing, that I'll be using this j pointer to print my even numbers, and I'll be using this one I equals to 1 to print my odd number. How I'm going to do that, you'll see in a while. Okay, so uh, we have to keep the check that while j is less than equals to n, because we need not to cross the number n, हमें n को cross नहीं करना है किसी भी हाल में. We have to keep the range less than n or equals to n. Okay, so there is one more catch here. If you just simply do as system out here, the you will get most probably TLE in this case, TLE here. Okay, why this is because of the CSES compiler, it throws somehow TLE for using system.out.println here. So to make this a complete submission, you have to use string builder. Most of you might be aware of string builder. Okay, if you're not, you should definitely try to read it via some article. Basically you can refer GFG, they have a very good article on that. So you can read it. It's and what it does, that it basically appends the number in O of 1 time complexity. Okay, so I will add j, and we have to keep spaces between the numbers. And what I will do, that I will just increment it by 2. Similarly, the thing which I will do is for I. Okay, so here it will be I, and here again it will be I. So how it will work, that for first j equals to 2, it will first 2 print 2, then again it will go to 4, then 6, then 8. Similarly for odd numbers, it will first print 1, then 3, then 5, and it will go on till it doesn't cross the n. Okay, and at last what we will do, that we'll just print our string builder, and let's try to run it and see if we get the desired output or not. Okay, so let's see if okay, so 24135. Okay, so here is given that if there are no solutions, print no solution, and if there are several solutions, you may print any of them. So it doesn't need doesn't specified that, oh, this will be the only answer. There can be multiple answers present for this number 5. As you can see, here is the one answer, here is the one answer. Okay, so let's check for our base cases. That is for 1 we should get 1. Okay, we are getting this. For 2 we should get no solution, and again for 3 we should get no solution. Okay, fine. So let's try to submit it and see whether it's get accepted or not. And the number, the question was permutations. We'll open and try to submit it. Okay, so let's see. Yeah, so it's got submitted. Okay, so you can basically try using s out here. Let me show you that it will give you an error. Okay, and why it will give you error? Because basically the working of system.out.println is a little bit slower in Java. So that's the case, because of which it gives TL in this. Okay, let's try to submit it with system.out.println uh, permutations. Okay. Mm, yeah, see, for the last five cases we are getting TLE. Okay, so that's why I used a string builder here, because appending in string builder is really faster, and you should definitely read about this. And I think if you are solving CSES problems, that you must be aware of this string builder thing. If not, then you can surely check GFG articles. Okay, fine. So we'll continue the next problem in the next video. So thanks for watching.